Hello viewers, and welcome once again. We are still under logic, Christ Almighty God's Algebra. Today we are going to treat De Morgan's law. We have De Morgan's law by conjunctive statement and De Morgan's law by disjunctive statement. But we're going to start with De Morgan's law by conjunctive statement. Let us start. De Morgan's law. De Morgan's law. Not bracket P or Q is equal to not P and not Q. This is a typical example of De Morgan's law by conjunctive statement. You will see that in this equation, you will find out that whenever the left hand side of the equation is true, also the right hand side of the equation must also be true. In the same vein, whenever the right hand side of the equation is false, also the left hand side of the equation must also be false. We say that the equation is a logical equivalent. That means it is law. So why do we call it De Morgan's law by conjunctive statement? Because this and connective combines not P and not Q together as a statement. So we call it conjunctive statement. That's why we say that it is De Morgan's law by conjunctive statement. We are going to prove this statement that it is De Morgan's law. Let's prove it. So prove suppose not bracket P or Q is equal to not P and not Q. We assume that the statement is true. That means not bracket P or Q is equal to not P and not Q. We assume that it is true. So it becomes our hypothesis. Since the statement is logical equivalent, that means whenever the left hand side of the equation is true, also the right hand side of the equation must also be true. In the same vein, whenever the right hand side of the equation is false, also the left hand side of the equation must also be false. We say it's logical equivalent. So since it is not equivalent, we can transform it to biconditional statement. So if and only if not bracket P or Q, if and only if not P and not Q. We have now transformed it to biconditional statement. Since whenever the left equivalent is true, also the right equivalent must also be true. In the same vein, whenever the right equivalent is false, also the left equivalent must also be false. So when you want to evaluate statement, there's no possibility of getting falsity, always truth. When we evaluate the statement, there's no possibility of getting falsity, always truth. You say the statement is tautology. Say is tautology being justified by logical equivalent. Being justified by logical equivalent. Now, since statement is tautology, that means not bracket P or Q, if and only if not P and Q is tautology. That means we can also transform it to conditional statement and it will still preserve equivalent. It will still preserve tautology. That means, you say if and only if not bracket P or Q implies not P and not Q. You will see that whenever you have now transformed it to conditional statement, you have now transformed it from biconditional statement to conditional statement. You see that whenever the antecedent is true, also the consequence must also be true. That means when you want to read the statement, there's no possibility of getting falsity when you read this statement, always truth. We say it is tautology. Is tautology. Being justified by logical implication. Being justified by logical implication. Now, you see that it preserves tautology. When you transform it from biconditional statement to conditional statement, it still preserves tautology. Being justified by logical implication. Since this statement is tautology, that means there's no possibility of getting falsity in this statement, always truth. When you evaluate it, you always get truth. That means certain that antecedent exists. Because there's no possibility of getting falsity in the statement. So you see that it's certain that antecedent is a proper implication of the consequence. So that we say that the antecedent exists. So we say that the antecedent is logical implication of the consequence. See, if and only if not bracket P or Q is logical implication of not P and not Q. So we have now deduced that the antecedent is logical implication of the consequence, not P and not Q. This must also be true. So if and only if not bracket P or Q is equal to not bracket P or Q. That means if this is the logical implication, it's also true that it is equal to itself. That means not bracket P or Q is equal to not bracket P or Q. That means not the antecedent, that means the logical application is equal to itself and it is true. Because whenever the left answer of the antecedent is true, also the right answer of antecedent must also be true. Whenever the left antecedent is false, also that antecedent must also be false. We say it is logical equivalent and it is true. So not bracket P or Q is equal to not bracket P or Q. Being justified by identity. That means the sameness. Being justified by identity. So if and only if not bracket P or Q is equal to not bracket Q upon not P. We have now transformed this P or Q to conditional statement. You now transform it to conditional statement. You still preserve equivalent. That means logical equivalent. So that means it means that P, not bracket, not P implies Q. That means not bracket Q upon not P. So he said that it's being justified by first etiquette law. By first etiquette law. So if and only if not bracket P or Q is equal to, you want to signify this statement, not bracket Q upon not P. You want to signify it. That means if you signify it, any statement that is positive will become negative. Anyone that is positive will become negative. Anyone that is negative becomes positive. Will become positive. So here, this is positive. This is positive. It becomes not Q. This is negative P. It becomes positive P. Becomes P. You will find that the statement has not intensified. It's no more equivalent. The right hand side now is now facet of the left hand side of the equation. Because this left hand side of equation is subset of the right hand side of the equation. We say that it is intensification of the left hand side of the equation. That means it's not grace, it's no more law. It's not grace. Because there are no more logical equivalents. Rather, one is subject to each other, and also one is also subset of each other. So you say is intensification of not bracket P or Q being justified by signification of law. Being justified by signification of law. Being justified by signification of law. So we have done a proof in signification of law. So you can go back to our previous tutorial to be acquainted with signification of law. Now I say if and only if not bracket P or Q is equal to. Now I want to revise this conditional statement that will not P upon not Q upon not P. You want to reverse it to conjunctive statement. Why I'm going to reverse it to conjunctive statement is because here is being related from disjunctive statement and we have not P, and it's further signified. It's further signified, and if signified is also changed. If it is the implication, if implication is positive, it will change to negative. If it's negative, it's changed to positive. Here it is negative, and when it's signified, it becomes positive. Also, we want to revise it. It's no more going to be in conjunctive statement by which the not P, this implication, not P, is being generated. But this one now, not the negative. Now, You go to be now conjunctive now, no more disjunctive. It's going to be conjunctive because it has not been signified. So it's going to be not P and not Q. Being justified is now equivalent to this side. The equation now is now equivalent. You say it's being justified by by Christ the Almighty God's grace. Being justified by Christ Almighty God's grace. Now, I have now proved the statement that not bracket P or Q is equal to not P and not Q. If you say thus, not bracket P or Q is equal to not P and not Q. We have now proved the statement, but it is law. Since it is law, we are going to prove the converse so that by the principle of exceptionality, we will then establish that not bracket P or Q is equal to not P and not Q is De Morgan's law. So we're going to prove the converse. Let's prove the converse. So conversely, not P and not Q is equal to not bracket P or Q. You have seen that the right hand of equation here has become the left hand of equation here. The left hand of equation here has become the right hand of equation here. You say that it is converse. So you want to prove the converse, that is converse also exists. Since it is logical equivalent, you say suppose not P and not Q is equal to not bracket P or Q. So we assume that the statement is true and is our hypothesis. Since it is true and used as our hypothesis, and the statement is logical equivalent, because whenever the right answer of the equation is true, whenever the left answer of the equation is true, also the other equation must also be true. In the same vein, whenever the left answer of the equation is false, whenever the right answer of the equation is false, also the left answer of the equation must also be false. You say it's logical equivalent. Since it's logical equivalent, we are going to transform it to biconditional statement. That is, if and only if not P and not Q, if and only if not bracket P or Q. We have now transformed it to biconditional statement. And you see that whenever the left equivalent is true, also the right equivalent must also be true. Whenever the right equivalent is false, also the left equivalent must also be false. So whenever you want to validate this statement, there's no possibility of getting falsity, always truth. You say that the statement is tautology. Is tautology being justified by logical equivalence? Now, since this statement is tautology, we can also further transform it to conditional statement, and it will still preserve tautology. That means if and only if not P and not Q implies not bracket P or Q. You see that in this statement, I can transform it to another statement, and whenever the antecedent is true, also the consequence must also be true. So when you want to validate the statement, there's no possibility of getting falsity, always truth. You see that the statement is tautology. Is tautology. We see that we have now preserved tautology. Being justified by logical implication. Being justified by logical implication. Now, since the segment is tautology, there's no possibility of getting falsity. We then deduce that it is certain that antecedent exists. That means the antecedent is a proper implication of the consequence. So we say that if and only if not P and not Q is logical implication of not bracket P or Q. So we have now deduced that not P and not Q is a logical implication of not bracket P or Q. That's to say that it is certain that not P and not Q exist. And if this is true, this also must also be true. Say if and only if not P and not Q is equal to not P and not Q. That means the logical implication is equal to itself. So if not P and not Q is a logical implication of not bracket P or Q. Also, it is true that logical implication is equal to itself. That means it's logical equivalent. Because whenever the left side of the logical implication is true, the right logical implication also must also be true. In the same vein, whenever the right logical implication is false, also the left logical implication must also be false. They say it is logical equivalent and it is truth. Being justified by identity. That means the sameness. By identity. Say if and only if not P and not Q is equal to. Now we are going to intensify, because we're going to transform it to conditional statement. We're going to transform not P and not Q to conditional statement. That means to say that we have not Q upon P. We have not Q upon P. And you see that the equation is no more equal. That means it's no more log, it's now grace. Because the right hand side of the equation is now greater than the left hand side of the equation. That means it's now intensification of the left hand of equation. Because the left hand side of the equation is now subset to the right hand side of equation. So you say that it is intensification of the left hand of the equation. That means is intensification of not P and not Q. Being justified because it's through the Christ Almighty God's grace that we use to transform this statement, this not P and not Q, to conditional statement. So it's being justified by Christ Almighty God's grace. Being justified by Christ the Almighty God's grace. Now we are going to simplify the right hand side of the equation. We're going to simplify it. Say if and only if not P and not Q is equal to not bracket. Now since this P is positive, it's going to become negative. Since this not Q is negative, it's going to become positive Q. That means you have Q upon not P. Q upon not P. You see that it's now equal to the left hand side of the equation. The right hand side of the equation is now equal to the left hand side of the equation now. That now turned to law. So being justified by signification of law. So since I have not simplified the law, yeah, that becomes equal to each other. So if and only if not P and not Q is equal to. Now we are going to transform this conditional statement to disjunctive statement. That means not bracket. Reason why I'm going to transform it to disjunctive statement is here is being written here as P. The conjunctive statement, this not P is being written from the conjunctive statement, it becomes P. But it's further signified, it becomes not P. So it's more reversed to conjunctive statement, it's not reversed to disjunctive statement because it has now been also transformed again, it has now been changed. So that's why we are going to have P or Q. Being justified by first Ejike's law. So it's through first Ejike's law that transform it this conditional statement to disjunctive statement. So we have now proved the converse. You see the converse, we have now proved it that it is true. So we say, he concludes, we say, thus, not P and not Q is equal to not bracket P or Q. We then conclude the statement. Since you have now proved the converse, you have now proved the converse. So by the principle of essentiality, we then establish that not bracket P or Q is equal to not P and not Q. Therefore, not bracket P or Q is equal to not P and not Q is De Morgan's law. Now, I have not proved that Morgan's law exists. So at this juncture, we will draw our curtain. Thank you, viewers.